earthing. What does earthing mean to you, especially if you are an electrician or a homeowner or a business owner? Do you have a family, my top bosses? And especially if you do care for them, we are going to discuss the various earthing methods. We're also going to discuss about the common fails when it comes to earthing. The fail in an earthing system means that you will definitely get an electric shock and you might die. So that is what we are going to discuss today, my top bosses. Let me know if you are ready for our today's stream by simply hitting that like button, and I will definitely be guiding you through so that you are able to understand earthing in details. Majority of the people talk about earthing as if it is a by the way. Earthing has to be taken with a lot of weight. The same way as an electrician or as a homeowner, you take a live cable with a lot of weight and seriousness. Top bosses, let us get right into it. And I'm so glad to see majority of you right in. Thank you so much for joining. So I'm erasing this board so that we start everything from scratch, so that we work together from the time that this board is completely empty until the time that we will fill up this board with a lot of knowledge that is going to help you. Majority of you watching me right now have not subscribed to this channel. We are about to get 100,000 subscribers. Why can't you be part of history that is in the making by only being a subscriber? Top bosses, thank you so much for joining in. And today I have these colors right here. We know for a single face, especially in most countries, this is definitely the live or the line or the face. And this, the black one, is definitely the neutral. But in the USA or even Canada, you know, the Northern America, the black is the hot wire or the hot line, and then white is the neutral. Green in many cases appears to be a symbol for earthing or a color code for earthing. Blue is also a line. We will get to it and discuss much more, but my top bosses, today we are definitely discussing about this important aspect which is called earthing. Safety is what we are talking about today, my top bosses. And if you know about electrical installation, what is this, my top bosses? What does this mean? What does this simplify or what is the symbol for that? What does that mean, my top bosses? Let me know. Of course, if you have sat in a class of electrical physics and all that, you know what that means. So my top bosses, what is the meaning of that? Top bosses, let me know on the charts. Yeah, let us get right into it and let us be very proactive on our today's chat, my top bosses. Let it not be dull like yesterday. Yesterday, our chat was not that active. Why? Why, my top bosses? And the way you know that I'm very proactive on these streams, and I want to thank you so much, my top bosses, because you have always supported us in our content creation. So our today's topic, like we have said, is earthing. Is that visible, my top boss, from where you are sitting? What is earthing? We'll definitely be defining earthing. We will also be talking about the many mistakes that people commit when it comes to earthing. So number one, we are discussing about what, right? How do you arrive at earthing? Yeah. Why is earthing important? So the what is earthing is how we define earthing. Earthing is definitely the earthing basically is directing all the excessive charges, bad charges to the ground, you know, and that is why I have this symbol here, you know. What is it signifying? So if we have bad charges, excessive charges, it goes all the way to the general earth mass, you know. So if we have this as the earth, So we have this as the earth rod, right? So this is the earth rod going all the way in. We can also have something such as this one. This is what we refer to as an earth mat, right? So this one is an earth rod, and then this one is an earth mat. Is mats written like that. Top bosses, if you are already getting something that you didn't know before, smash that like button. And also, if you can relate to whatever we are discussing today on this whiteboard, smash the like button. For those top bosses who have not subscribed to our channel, you are missing out on the making of a history where we are geared towards 100,000 subscribers. Unbelievable. Top Heights started from way back in 2022. We were stuck at 66 subscribers for so long, and right now we are at 73,000 subscribers on the road to 100,000 subscribers, my top boss. So be part of this history that is definitely in the making. Okay, away with that, we are discussing about earthing. What is earthing? Earthing is the direction. You know, earthing is the act or the purpose. Ah, God, goodness. Let me just Google. Let me just Google. What is earthing? Let me just refresh myself. Earthing. What is electrical earthing, for instance? You know, I just earthing meaning, yeah, the process of redirecting dangerous electrical currents into the ground. Myself, I learned that it is the general earth mass. So not the ground, but earth mass. Or is it the ground? You know? So basically, it is directing of these charges, all of these charges into the ground. But we may want to know why the ground. Is the ground a good conductor of electricity? The answer is yes. So the ground generally will attract these charges, will absorb these charges, and that is a very, very safe area for the charges to be dissipated into the ground. Okay, we cannot say entirely that the earth is a good conductor of electricity. There are factors that can cause the earth to be a good conductor of electricity. All right. So if these charges are redirected to the ground, what is the ground supposed to do with it? So once these charges are into the ground, they will find their way back to the source, which is the transformer, all right, the TX. So if this is a charge, let's have it pause. Or is it negative? Negative charges, yeah? So if we have these charges going all the way back to the transformer, it will go all the way to the, especially if it is a three-phase transformer, right? And at the output, we have a Y. And of course, we have this common point. What is the name given to this common point? X. So if I may have this one, 2, and then this is 3. So this one, I can also have this one right here. And so we can as well have this at this point. So this one is, what type of a connection is this at the transformer? Yeah. What type of a connection? Let me know if you understand that, my top bosses. So at the transformer, what we do have right there is what we refer to as a delta. And then this one is a star connection. At the center here, what is this? I have 1, 2, 3. All these are lines or positive, sorry, not positive, but live, or this is a phase 1, 2, and 3. All right. So this one is a delta. This one is a star connection. So at the secondary, we have this one as the neutral. So there's middle point here, or the connection at this point is definitely the neutral. All right, so that definitely is where we get our neutral connection from, making it a delta star connection. And why is that important? It is because, assuming that we require a single phase, we require a phase, and then we will require a return point that is a neutral, so that we can complete the circuit top boost. Okay, that is not a good representation when it comes to electrical, but my point is electricity comes from somewhere, and then it goes through the appliance or the load, and then it goes back, and that is how a circuit is completed, isn't it? So assuming that this one is an appliance, no, let us just use the load. This one is a load, right? It could be a bulb, a microwave, a heater, whatever it is, but a load. So this one is the phase or the line, and then this one is the neutral. It has to go back. Now you may ask me, John, where does earthing comes to play? What is the importance of earthing? How does it come about? Earthing is very, very important, because at this point where we have that, we are definitely going to have something that is very, very important. I'm feeling, okay, that is our transformer, that is our earth mat. What should we erase? Let us make good use of this portion here on our whiteboard. If, let's say, we have a microwave here, right? So I'm just trying to come up with an image. This is definitely our microwave, and so that is the screen where you can watch your sandwich burning, and this one is plugged to the wall, isn't it? Plugged to the wall at 220 volts. So we have something that is very, very important, like I was talking about here. This is the load. So we have the phase or the line, and we also have the neutral. The earthing for this microwave will only work only and if only the connection of this metallic surface. So you already know that this is the metallic part of the microwave, right? Is connected to the socket or the wall outlet. So that this cable, which is coming from the microwave, has 3 pins, which is line or phase. And it also has something that is very, very important, which is definitely earth connection. If those are missing, then it means there is a problem. So this is a heater. This is a heater. This is a top plug. Assuming that this one is a microwave with this top plug, earthing has to be very consistent from the cable itself. So this one being a top plug, if you understand this basic, as much as it is a very simple concept, you will generally understand earthing. All right. So this is a top plug. This top plug is connected to a cable. In fact, let me just use this one right here, my top bosses. Okay. So we have this cable. This is the best way to understand earthing. The coil itself will definitely be connected to a plus or opposite. No, the coil itself is connected here through these 2 pins, so that once the current is flowing through it, we have the neutral as well as we have the phase or the line. And that is why here we have this indication that this is L, this is N. What does that mean? Line, neutral. And then, of course, this one is indicated E. You see there? Are you able to see that? That one is an E, meaning earthing. And you can see it is longer than the other pins, so that when you insert it inside a wall socket or inside an extension cord, it will definitely pave way for connection. It will first be connected. And so today, my top boss, we are diving deeper when it comes to this subject. So this pin is longer, so that when it is connected in the wall socket, it will first of all make contact with the connection here, the earthing connection, which is this one, before you can even connect this heater. If, for instance, someone accidentally comes in contact with this heater, already the earth pin or earthing pin has made contact in there. You can even see, my top bosses, that this one was intentionally made to be at almost at the surface. You can see is it, let me not say the mabati, but you can see that inside. I don't know whether you're able to see. You can see that copper-like part inside right here. All right. And for the other two pins, you cannot see that. Why? Why is that so? So that when you insert this plug inside there, you see which one goes in first? It is definitely the earth pin for safety purposes. So once it goes in, it is already in contact right there. So if you plug it in, my top boss, it has already made contact with what? The earthing connection. Is that so simple to understand? I believe it is. Once it has made contact, it means that the protection is on. But like we said, if this cord is not in contact with the metallic part of the microwave, just the same way, if that connection, that pin, is not in contact with this part here, you see this part? So this one acts as the earthing or the safety net. So it is connected with this earthing pin. So for us to just prove that, we will definitely test. And so here I have my digital multimeter. What we need to test here, simple, is to test the continuity, right? The continuity. So from the plug, once the plug is inserted inside the socket, it is supposed to make a continuity all the way up to this part here. So what I'm going to do, my top bosses, is to simply remove this cover, remove the cover on the top plug, so that we are able to record the continuity. So using my tester here, I'll simply unscrew that, and then boom. Oh, everything pouring down now. So I'm going to share more on the features of the top plug, but for this screw, we are supposed to have it right there. This is the best class that will help you understand the basics when it comes to electrical. All right. So these are just the screws for what we have been talking about, this is definitely the earth connection. This is the line, or you can see even the fuse. The fuse is attached to the line. It is not attached to earthing or neutral, simply because this is where the connection from the face gets in, and then this is the neutral, this is the earth connection. Now my point was that that pin, the earthing pin, is intentionally longer, so that when it gets to the sockets, this is the socket, when it gets to the socket, it will first of all make contact right there. So we want to test, in fact, even before the other pins get in, all right, will we get a continuity? All right, so like that. You see, it is not already in, but we want to prove, is it already making contact with the earthing connection? So using our digital multimeter, that is what we are going to do. Today I'm alone here in the studio, so I'm going to have a bit of a struggle. My top boss assistant and the one, the only Margaret, is not here, so I will do everything by myself. All right. So let us first of all agree with me that this is what we are going to do. We're going to unscrew that and then have to attach yeah. So we will unscrew here, or even without that, we can simply place one of the probes right there, and then at the back you can see. So let me just demo it from the front of our camera. So I can simply attach it at this point, and then all that we need to get is a beep. So we get a beep. Is it really in contact? Yes, it is in contact. And mark you, the pins, these other two pins, are not yet in contact with are not yet fully inserted in the socket. So that is what we have. The moment we insert it like so, and then record in fact, even when the switch itself is off, and then switch it, before we switch it on, record the continuity between this earthing point here and this earthing that is in the socket. Should we get a result of continuity? Will it beep, my top bosses? So that is what we are looking for. And how are we going to do it? Procedurally. So this is my multimeter. So we want to get some zeros and a beeping sound so that we know that there is continuity. So we will test between this long pin, or the earthing pin, and this part right here. So we'll simply insert it like that, and trust me that we have connected it there, and then go ahead and touch that, and what you can see is a beep and also zeros, meaning very, very little resistance, almost negligible. All right, so that is what we have. Now moving on, my top bosses, we have said what is earthing. Earthing will now be connected from this microwave or whatever appliance that you have, all the way to the plug, to the socket. We have already demonstrated that it has to be continuing. So from your appliance through the cable, it has to be continuing all the way to the wall socket. If there is no continuity up to the wall socket, that will fail, it means that you will receive an electric shock in case there is an in case there are charges on the microwave, or in case there are excessive charges, especially that are on the surface of the microwave, especially for these metallic appliances. That being said, the wall socket is also another. It has to go all the way to the consumer unit. All right. So apart from our L and N going all the way to the MCB, where many people put a lot of focus. So we have the MCB, we also have the earth bar. So at the MCB, we will have the earth bar. I mean, at the consumer unit, we'll have the earth bar, we'll have the neutral bar, and we'll also have the MCB. So as much as we are connecting the line, the neutral, to the MCB, as well as to the neutral bar respectively, the earthing has to be continuing all the way from the sockets. So this is where the wiring comes in handy. The wiring from the sockets, from the lighting points, all the lighting points have to be in contact with the earth bar in the consumer unit. Customer consumer unit. That one you have to check properly. Apart from that, apart from getting all the way to the consumer unit, what we need to be sure about is from the consumer unit, that continuity of the earthing has to go all the way to the meter board, and then from the meter board, it has to go to the earth rod. Top bosses, if you are getting value from our today's stream, smash that like button. And if you have not subscribed, be part of this history on our way to 100,000 subscribers, so that when we will be celebrating our 100,000 subscribers, you will be part of the entire journey. Thank you so much, my top bosses who have been here watching us consistently, who have subscribed from the day one. We really, really do appreciate you. Thank you so much for being here, my top bosses. All right. So moving on, at this point, we have the earth rod, and it does not end there. All right. If you have this earth rod, it has to be working. Whether it is an earth rod or an earth mat, it has to be working perfectly. So that in case our microwave here or the customer's microwave has any charges, it will go all the way to the top plug, the socket, right? So even if this is the item that you are using or the customer is using in the house, there has to be that continuity, my top boss. It will go all the way from this pin right here, like we have discussed, and to the socket. If there are charges here, get to this cable, right, transmitted through this pin to the wall socket, like we have said, the wall socket. And at this point where you connect your cable, the cable that is connected here, 3 cables will be connected at this point, the earthing, and then the neutral. Line, earthing, neutral. Line, earthing, neutral. And as you can see from this plug, this is the earthing line and then the neutral, which is also in contact at this point. From there to go the way to the consumer unit, and then from the consumer unit to the meter box. Okay, so this is our meter box. And then from the meter box definitely goes down there to the earth or to the ground. So that flow of bad charges, dangerous charges from the appliances through the cable, through the socket, still everything is not safe all the way to the CU at the earth bar. And then from the earth bar, the charges still find their way to the meter box. And then at the meter box, they will be dissipated all the way to the ground very safely. Now, again, the customer is still not safe if this connection from the meter box to the earth is broken, or from the socket to the consumer unit is broken, or from the consumer unit to the meter box if there is a break, or there is no continuity of the earth wire, it means that the customer will have it rough. And having it rough definitely means that the customer will be electrocuted. Hmm? Great question from our top boss, the one, the only Morage says, how deep should be an earth rod be? So in many cases, you find that the earth rod is probably around 3 to 4 feet. Okay, so the depth will definitely be dictated by the earth rod. So that is a very good question, our top boss Margaret. So from, again, remember, the earth rod requires to have that clamp where the earth cable is attached. All right, and therefore that is where we usually have what is referred to as an earth pit or an earth inspection pit. Initially, it was directly above the ground, but what we are trying to avoid is to have that directly above the ground, but instead have a wall where you will have an inspection point so that even the moisture or the rain, the impact of the rain will not be direct on the pit or on the earth inspection pit or point, but instead have it on the wall so that we can reduce the impact. Now, from the wall, we will definitely have the earth rod immersed inside here, okay? And then we'll have the inspection point at this point. So depending on the depth of, on the height of the earth rod, that will definitely be dictate the depth. But again, when it comes to something that is referred to as the earth pit, how deep should it be? That one is debatable depending on whether you will achieve the correct readings for the earth resistance test. In our next video, we will be talking about top bosses. Are we back? Sorry about that interruption. Sorry about that interruption, my top boss. Good. Thank you. We are back. We are back like we never left. Thank you so much, my moderator, the one, the only top boss Maggie. All right. So now, my top boss, what we are discussing is that there has to be the integrity of the earth. So the earth matters a lot. Now, this is where, after we discussed all the ways in which these charges will flow to the ground and what can stop them from flowing or creating a very good path that will allow the charges to flow to the ground. Now, the elephant in the room also is the ground. Is the ground able to absorb the charges that are coming from the leakages, either in the microwave, the appliances, the lighting, or the electrical installation in the home? If not, then they will be stuck somewhere. They will flow all the way to the consumer unit, and then they will be stuck. So anyone who comes in contact with them, and especially if they are barefoot, they will absorb the charges, and that is how electrocution occurs. Creation of an easier path for the flow of charges. So if you are in contact with that path or that line or that cable or that metallic case, and then you are electrocuted, that means the charges flew to you to the ground. They were creating, or they were finding, an easier or a safer path, and you happen to be part of that circuit, and that is how you receive an electric shock. All right. Have we understood up to that point? Have we understood, my top bosses? Smash that like button if you are already into the zone. All right. Margaret says, thank you for the good explanations. Thank All right. Margaret says, thank you for the good explanations. Thank you too for sticking in these chats. Our top boss, Marga, you should be here doing the most. Right. So let me just also recap what we have discussed for our top bosses who are joining us right now. We are discussing about earthing, how earthing comes to play, how people get electrocuted, how they can stop the electrocution from happening, and we are definitely coming to an agreement that indeed there has to be a safer path for the charges to flow from the microwave, from the fridge, from the socket all the way to the consumer unit, the meter box, and definitely to there has to be a path. It has to be very, very uh, functional. If there is a break or a broken path, then it means that someone will suffer an electrical or an electric shock. Now, the ground matters a lot. The ground where the charges are dissipated matters a lot. What are some of the qualities of the ground? Number one, it has to be wet. Okay. Probably that is debatable, but the ground has to be able to absorb charges. Before we get to a wet ground, absorb the charges. Number two, it has to be moist. That is how we discussed about it being wet. And another important thing about this earth, it has to conduct or basically to absorb these charges. So if it is rocky, it will not. If it is dry, the efficiency will be very low, or it might not absorb. So those are some of the qualities of the ground or the earth that is supposed to absorb these charges. All right. Now, for you to know that this ground is the best for charges to be absorbed, we measure using something that is referred to as an earth resistance tester. An earth resistance tester will test the resistance of this earth in relation to absorption of the electric charges that flow from an electrical installation to the earth. If the resistance is too high, it means that that is the resistance it offers to the absorption. Remember, we want to absorb these dangerous electrical charges from the electrical installation, from the electrical appliances, from the electrical devices to the ground. If the ground is hostile, wow, like a political ground, if it is hostile, it will not allow the flow of these charges into it. It will probably repel. It will definitely just not accept the charges. So the ground has to accept. If it doesn't, it means that it has a higher resistance to the absorption of these electrical charges. Now, my top boss, what are the factors that lead to the ground being resistant to electrical charges? If at all the earth does not, it is very dry, it is very rocky, all of those are contributing factors. In the next live video or in the next live stream, we will be discussing about the earthing or the earth basically, or the ground qualities. We will also be discussing about an important aspect, which is the acceptable resistance for various electrical installation. For domestic, what is the allowable, what is the allowed resistance of the earth or of the ground for domestic, all right, for industrial, or even for commercial. Remember, uh, we have where do I erase now? What can I erase here? Can I erase this part? So we normally have domestic. What is the value for an earthing resistance test for number one, domestic? Number two, we have commercial, and number three, we have domestic. Sorry, not domestic. Come on, John, you're repeating number one, making things to be easier. Life is not that easier. We have the industrial, right? So we have domestic value, commercial value, industrial value. How are these figures achieved? How do you test the earth resistance of a certain place before you can actually install earthing that works for either domestic, commercial, or industrial? What is the value that we are expected to achieve for domestic, commercial, and industrial? That is what we'll be discussing in our coming live stream. Thank you so much, my top bosses. I will also be guiding you on how to use great for coming along and also being part of this stream. I really do appreciate that. And if my top boss, you have not subscribed to our channel, subscribe so that you don't miss that episode. It will be awesome. You will learn a lot. You will gain a lot from it. We will be demonstrating using an earth resistance tester. We will also be sharing the values. But today I'm giving you a homework. Let us go and research what is the values that are acceptable for earth resistance test when we talk about domestic, commercial, and industrial. If you don't achieve those values using an earth resistance tester, then it means that the earthing in that property or in that setting is definitely not going to work. Thank you so much, my top bosses, for watching this stream. I have been your host, John Gatehi, and on behalf of our top bosses who are definitely working with us here at Top Heights, I really, really appreciate you. I appreciate your time. Thank you so much. Goodbye for now. This is Top Heights Electricals and Solar. Have a fantastic time. Earthing, how important is earthing? That is what we've been discussing. So that is earthing. We have discussed about why you need to have earthing that works. We have talked about the distribution of the transformer right there. We have also discussed about the various ways that the charges will go to the ground, and we have also talked about the qualities or characteristics of the earth or the ground to absorb that. We have also discussed about the journey of Top Heights Electricals. Currently at 73K subscribers, we were at 66, and we are on our way to 100,000 subscribers. Are you going to be the person that will be part of this history in the making? Top bosses, subscribe to our channel.